Welcome to the class, ninth standard mathematics. So the goal here is to connect you people to Heron's formula. Before getting into Heron's formula, I thought of introducing triangles to everyone. That's how this topic is coming in, into picture. So the Heron's formula is part of chapter 8, Karnataka State syllabus, and chapter 10, CBSE syllabus. Okay. Let's start from the beginning. Assume something happened, maybe Big Bang, and the world is created. Okay, so the world again further can be classified broadly into physical realm and metaphysical realm, right? So physical realm talks about matter and energy, whereas non-physical realm talks about some of the spiritual worlds, mind, consciousness, etc. And our focus is physical realm. And again, physical realm, we got many branches here. We got science, arts, history, philosophy, religion, personal access, and we can list some more branches or the branches to understand the physical realm, right? So, but then coming to the science, right? Science again is a science. We got multiple branches of science. For example, natural sciences, formal sciences, social sciences. Maybe looking at formal sciences, right? We have a mathematics as a formal science. Computer science can be a formal science. Electronics can be a formal science. Let's get into math. Whereas physics, chemistry, and biology, I can place them under natural sciences, right? So when mathematics again further can be classified, divided into many other branches like arithmetic, algebra, geometry, calculus, statistics, right? Let's focus on geometry now. Geometry again further can be classified, into Euclidean geometry, non-Euclidean, analytic, or projective, differential, geometry, and multiple other things, right? So taking Euclidean geometry, and it talks about fundamental shapes. For example, dots, circles, lines, triangles, spheres, cubes, etc., etc., etc. So now the focus of our this session is triangles, which I can place under fundamental shapes, which is part of the geometry. Now that we got the context why we are learning geometry, basically it's an attempt to understand the world. Okay, the what is this world? This world is made up of physical realm. This world of made up of matter and energy. Matter occupies space. Matter, so it means it has got dimensions. It has got a shape, right? So this entire world is made up of different shapes, simple and complex. Before understanding the complex shapes, it's always good to understand some of the fundamental shapes which we find everywhere, and who in turn makes a complex shapes, right? Some of them are some of them are points, a dot, lines, planes, triangles, quadrilaterals, polygons, circles, spheres, cubes, etc. So look at this. The points, it has got no dimension, right? Whereas line, it is a one-dimensional shape. Whereas planes, triangles, quadrilaterals, polygons, circles, they all are two-dimensional, the shapes. Spheres, cubes, etc., etc., they all, three-dimensional shapes, right? So now these makes the fundamental shapes, and complex shapes are in turn made out of these basic shapes. So our journey in this class is to understand some of these fundamental shapes, and the focus of this class will be triangles. Yeah, triangle. What is triangle? It is the most fundamental shape in geometry. It's a specific type of a polygon. Of course, it has three sides, three angles. It's a closed figure. It can be classified into multiple types. We'll see it later. We can classify them on sides or angles. We'll see them later. To start, let's understand with the parts of the triangle. We can say triangle has mainly three parts. Look at the image. Triangle means it has got, what are the things? First is it is a word. It has got vertices. Okay, vertices. P is a vertices. R is a vertex. It's a vertex. Vertices is a plural. Vertex is a singular. Okay, so Q is a vertex. So it has got a vertex 1, vertex 2, and vertex 3. Totally 3 vertices. Right. and it has got sides. Okay, for example, side 3, side 2, and side 1. It's a straight line. And it has got angles. Look at this is the angle, this is an angle, angle 2, angle 3. Right. So what are how many parts triangle has? It has got 3 parts: vertices, sides, and angles. Right. Let's talk about vertices. The points where two sides of the triangle meet. Look at it. Side 3 and side 2 are meeting at vertex 3, which is P. Alright. Similarly, vertex where two side 2 and side 1 are meeting. Okay. How many vertices it has? Of course, it's visible there. 3 vertices. Triangle has 3 vertices. Now sides. What is side? A side is a straight line. Now straight line segment it is. Okay. This is a line segment. Straight line segment that connect two vertices. For example, P is a vertex, Q is a vertex, and I'm drawing a straight line here, and this is I called a side of a triangle, right? So it's a straight line segment that connects two vertices, and it has got 3 sides. Triangle has got 3 sides. So 1, 2, 3 like that, right? So next one, the third one is the angles. So angles are the measures formed by two sides meeting at a vertex. For example, here look at it. So side 1 and side 3 are meeting. Here it is some measure. I can do some measurement here, right? How much is side 2 away from side 1, right? It measures formed by two sides meeting at a vertex, right? So now how many angles it has? It has got 3 angles. Now that we learned the parts of the triangle, which are vertices, sides, and angles, let's learn about the different geometric measures that we always most of the times deal with triangles, right? So imagine a triangle like that. What are the different geometric measures that we always keep talking, right? We can classify these geometric measures of a triangle under lengths, areas, ratios, angles, distances, and some other topic. Okay. So let's go with start with length, the geometric measures which fall under length category. The first one is side length. Okay, what is side length, right? We have a sides AB, BC, and CD, CA, right? So what is the length of these sides? We come under side length, right? And then we have perimeter. So what is perimeter, right? So it is a sum of all the lengths, sum of the lengths of all three. For example, A, B, and C are the lengths of each side. Then perimeter is A plus B plus C. Then median length, right? So what is the one more, the geometric measure which falls under the length, right? Median, okay, the length of the median. What is median then, right? So this way, these are the length of the lines, okay, connecting vertex to the midpoint of the opposite side. For example, this is my vertex, right? And opposite side is BC, correct? So then what I will do is I'll find a midpoint of this BC. D is the midpoint of BC. I will join the vertex A, okay, to the midpoint BC. And what is this length? That's called median. So in the same way, BC or BF is also a median. CE also a median in this particular case. And yeah, we learned about medians. What about altitude length? Altitude, typically we talk about height of a triangle, right? We refer them as a altitude as well, right? What is this length? Length of the height, simple. Okay, or height of a height of a triangle, or length of the, it's the, what we how do you define? It's a length of the perpendicular line from vertex to the opposite side. For example, assume take A as a vertex and opposite side is B, right? Let me draw a perpendicular line like this, and this angle is of course 90 degrees, remember. Okay, this is a perpendicular line. Then what is this line, length of this line? That's called altitude length, or we can also call it as the height of this, the triangle. Oh, but what about next? We have an angle bisector and length of this angle bisector. So look at it. So you see, this triangle makes the three angles, right? This is an angle, and this is an angle, and this is an angle. Couple of lines. Now, if I draw some line from vertex to say some point here, and it might bisect into half of it. Okay, for example, if it was 60 degree, it may divide bisect the angle into 30 and 32 angles, right? And what is the length of the line which bisects an angle? Okay, that's again angle bisector length. Okay. Similarly, we have a perpendicular bisector length. Okay, what does it mean? Okay, refer to this in image here. These are all these lines are perpendicular bisector lines, and there is a way you can bisect this side. Okay, okay. So the length of the lines that bisect a side, individual side AB, for example AC, lines that bisect a side of a triangle at a right angle. Okay, so what is that length? See, it has to bisect, it has to be right angle both. So that length we call it as perpendicular bisector lengths. Okay, these are couple of geometric measures which we can place under length. Now let us consider some more geometric measures which I can place it under areas, right? So now area is one thing. Okay, what is, consider this the triangle. What is area? It's a measure of enclosed space in the by the triangle. Of course, triangle is a closed shape, right? How much is space is enclosed within the closed shape, the triangle, right? So we call that as a area, and we will define it by formula also. Off into base into height. Okay, let's go for one more kind of the some more kind of geometric measures which where we can place it under ratios, right? So now look at semi-perimeter. So we already learned what is perimeter. Perimeter is sum of all the sides, length of all the sides, right? So now sometimes we might be interested in half of a perimeter, semi-perimeter, right? So what is semi-perimeter? It is half of the perimeter of the triangle. That is a plus b plus c by 2. That we generally refer to it as a yes. And one more, the ratio we typically keep referring while we deal with the triangles, right? Is in radius to circumradius ratio. What is in radius? Let's see it. Okay, okay. It's a relationship between radius of inscribed circle and radius of the circumscribed circle. It's a ratio. Look at the it's one. See, this entire stuff is a it's inscribed circle. See, look at it in the inside circle, that is inscribed circle. You know, for that inscribed circle, all three edges are tangent to the circle. It means it touches. That's all. In a way, circle touches the all three edges. The other way to put it, the sides are tangent to the inside circle, inscribed circle. And there's another circle, we call it as a circumscribed circle, where it is outside the circle but passes through the all three vertices, right? And the ratio of these, the radiuses, we call it as, we are also some many times important. Now, let's go get into angles, right? So consider angle which where I place some angles and vertices names and sides, right? So whenever we deal with triangle, angles are the primary thing we always refer to. Okay, okay. It's measures of three angles of a triangle. Okay, how much is each degree? How much is this degree? How much is this degree? Right? And one more thing, if we always we need to be careful, what is the sum of all the angles? Okay, typically for a triangle, it's always 180 degree. We should be make sure of it. Are we making sure that sum of all angles are 180 degree, or does it really make sense like that, right? And one more thing we are generally interested is exterior angle. Okay, For a moment, extend an angle formed by one side of a triangle and an extension of adjacent side. For a moment, as here, CA is a base of this, triangle, and extend this CA to E towards E. Now look at it. This BAE, it forms an external, angle. And typically for equilateral triangle, it will be 120 degree because inside angle is 60. Total should be 180, so we get 120. Typically, otherwise we generally talk about how much is this exterior angle. Yeah, let's get into distances. So what are the distances we keep referring when you talk about our triangle, right? Just need to think of an image here. One of the thing is centroid. Okay, what is centroid? The point. It's a point, right? Remember this point, right? Okay, the point inside the triangle. Remember, okay, it's a point where the medians intersect, and we call it as a center of mass, right? Remember, always a triangle need not be always a very symmetrical, well balanced shape. Remember, right? Here in this itself is like too much of a length here, and width is quite more here, right? So ideally speaking, where is the center of the mass lies here. We need to find it out in the real world, right? So that we can balance it, the particular shape somewhere, right? So that's how do you find the center of mass? We find the medians, and it, the center is the point where these medians intersect. Then what is the question is, what is a median? I told you last time, right? It is a point from the vertex to the midpoint of the opposite line. You join a vertex and the midpoint of opposite line, and that is one vertex. Similarly, do it for all vertexes. Okay, and where this point joins, that's called centroid. One more, the geometric measure we keep using, once in a while, often is orthocenter. What is orthocenter? It's a point where altitudes intersect. I told you, altitude means height, right? We draw a perpendicular line. So, for example, this one, we draw a perpendicular line, for example, here from this point. Okay. Okay, just imagine it's a perpendicular line. So for example, this line, and what is this length of this, this line? Okay, so that we so assume it is a perpendicular. Let me draw a perpendicular line, for example, here. Okay, the length of this line, we call it as a height. Okay, so where these 3 points meet, okay, that's we call it as altitude, orthocenter. Okay, next, let's couple of more concepts again. We have a circumradius. Okay, and we have, what is the meaning of circumradius? It's the radius of the circle that circumscribes a triangle, for example, outside one. Okay, circumscribes, this is circle which passes through all three vertices. Okay, it circumscribes a triangle. This also, and what is the radius of this circle? This, okay, that's a point of interest many a times, right? And in radius, see, it has got one more radius inside it, right? So what is this circle touches all the edges at one place only, remember, each edge at one time. What is the radius of this? Okay, so that also is a the subject of interest for us. Radius of circle that is inscribed within a triangle, tangent to, if you look at it, all three edges are tangent to the circle inside radius. These are the few things, geometric measures, which are much required when you deal with circles in a complex, you deal with triangles. Okay. Okay, now that we have done with the parts of the circles and some of the listed and understood the geometric measures related to the triangles. Okay, let's now get into classification of triangles, right? I told you triangles can be classified either based on the angles or based on the sides. To start with, let's understand the types of triangles based on angles. We can classify triangles into acute angle triangle, right angle triangle, and obtuse angle triangle. So what is the difference is, let's see one by one, right? What is acute angle triangle is Acute means, typically think, acute angle means typically the angle less than 90, we call it as acute angle. Okay, right angle, we call it as, if angle is equal to 90 degree, we call it as right angle. Obtuse angle, if the angle is more than 90, of course, you should never be more than 180, remember. If angle is more than 190 degree, we call it as obtuse angle. So the angles, based on these angles, we classify the triangles. In the first case, you see this, all three angles, all three angles are lesser than 90 degree, lesser than 90 degree. Look at, this is 70 degree. Of course, since sum of all three should be lesser than 180, naturally it has to be lesser than 90. Okay, all three angles are lesser than 90 degree. This is one of the type of a uh, triangle. Okay, so now right angle triangles. What is right angle? One of the angle is 90 degree. Look at it. This one of the angle is 90 degree. And of course, remaining two angles are has to be acute. Okay, acute angle less than 90 degree. Why it has to be acute? Because total sum cannot exceed 90 degree or 180 degree. Sorry, right? That's all. So now what is the obtuse angle is one of the angle measures more than 90 degree. For example, look at it. It's more than 90 degree. Of course, naturally remaining angles has to be acute because sum cannot exceed 180 degree. Okay, so the acute angle. Can we have a angle more than can we have an angle triangle more than 180 degree? No, it cannot be, because the shape is no more closed if that is the case, right? See, one edge is passing like this, other edge is like this. It will never close, right? So, I mean, think for all the reasons up to the angle 90 degree, more than 90 degree, but less than 180 degree. These are the classification of the triangles based on angles. Okay, the other two angles has to be acute, you know that, right? Yeah. Now that we understood the triangles or classification based on angles, right? This is a time for us to understand or classify the triangles based on the sides of it, right? Let's go. How do we classify? First type is equilateral. What is equilateral? Equi means equal. Lateral means side. The triangle which has all three equal sides, all three sides equal to it, right? Second one is isosceles triangle. Third one is Scaline triangle. Okay, we have got three types of triangles: equilateral, isosceles, and Scaline triangles. Let's go one by one now. What happens or what's details, right? Look at this. So in the equilateral triangle, all sides are equal. So A, and A, all sides are equal. And all angles measure 60 degree. Naturally, it boils down to that. Basically, we classify based on sides. Since they are all sides are equal, it boils down to all angles are equal. Okay. So isosceles triangle. See, earlier it was all three, right? Now only two sides are equal in length. Look at this angle. This side is equal to this side, whereas this BC may be of different length. Then we call it as isosceles triangle. It means as simple as that, two sides are equal in a given triangle. It also boils down to two angles measure the same. For example, this angle is equal to this angle, whereas this is different. Okay, this boils down to this. Okay, we understood equilateral triangles, all sides are equal. We understood isosceles triangle, two sides are equal. Let's come to Scaline triangle now. What happens? What is this Scaline triangle? Scaline triangle, yeah, before coming to Scaline triangle, let's subclassify. Let us classify further isosceles triangles, right? This what do you call that, isosceles triangle, right? Isosceles triangle, which is of course the classification based on sides, right? This can be further classified based on angles. Again, acute isosceles triangle, right isosceles triangle, and obtuse isosceles triangle. Of course, the criteria I told it, I mentioned it in the just few minutes back, right? If acute less than 90 degree, uh, right, this is right, sorry, this is right. Okay, 90 degree and obtuse more than 90 degree. Okay, so isosceles triangles can further be classified as acute, right, and obtuse triangles. Okay, we are done with that, right? So now let's get into the Scaline triangles. What is Scaline triangle? Here all sides are different and all angles measure different. Okay. Okay. So now we understood Scaling triangle. Let's go for a summary of it. What is summary? Okay. What is summary? So what is summary is we classify the triangles based on sides and based on angles. Correct. So let's talk about based on sides first. So based on sides, we classified them into three types: equilateral, isosceles, and scaling. Okay. Equilateral, all three sides equal. Isosceles, two sides equal. Scaling, none of the sides equal. Okay. And based on angles, we classified again further. Okay. Into three types. What are those? Acute, obtuse, and right. In the acute, all angles are acute. In the obtuse, one is obtuse. In the right angle triangle, one is right. Of course, remaining is acute angle. This is a summary of it. Yeah, I wanted to just mention two words here because we keep using them very often. We use equal, we use congruent when we deal with triangles, right? So equal is generally is used for if the two things are two shapes are same size and magnitude. Okay, for example, a line which has got the same length, we say equal. Two lines are equal, right? Same area, okay, we say equal. Same volume, we say equal, right? It means equal is used for size and magnitude. Okay, whereas congruent is used when the size is same and shape is similar. When we are done dealing with shapes, right, we use congruent. It's used for shapes that have same corresponding sides and angles. For example, two triangles, when you compare, right, we use congruent, right? For example, we are talking about angle. This 60-degree angle is may not be same as, for example, this 60-degree, right? This 60-degree, right? This may be 160-degree and this may be 160-degree, right? Look at it. We cannot overlap them. Okay. Okay. So then both are 60-degree. Remember, we use congruent in this case. Okay. This is a summary. Yep. Let's talk about equilateral triangle maybe in the next class.